Hello everyone, I welcome you all for my YouTube channel. Myself Vasan Kumar S, working as an assistant professor at Mysuru Royal Institute of Technology. Today I have chosen the topic called Z transformation. So already you are aware of the transformations called Fourier transformation, Laplace transformation. So this is another transformation called Z transformation. So Z transformation is a tool to solve the problem called difference equation. Next, it plays a vital role in the analysis and representation of discrete time linear shift invariant systems. And also it plays a main application in control system of engineering and also in some advanced statistical problems. So next, we shall move on to the definition of Z transformation. See the definition of Z transformation. If un is a function of n defined for n equal to 0, 1, 2, 3, so on, etc. And if the value n is negative, then un will be 0. Un will be 0. Then Z transform of un is defined as, it is a notation, Zt is a notation. Zt, Z transform of un is equal to summation n equal to 0 to infinity z power minus n un equal to, as you expand this as n equal to 0 to infinity, if you give, the function will be retained with the terms containing z alone. That's why we have given that notation as u bar of z. So next we will study the another definition called inverse Z transform. So if you just you came to know there here Zt of un is what? Zt of un is u bar of z. Now transfer this Zt to the right hand side. You are going to get Zt inverse of u bar of z is equal to un. This is nothing but called as inverse Z transform. Is called as inverse Z transform. Inverse Z transform is called as inverse Z transform. Now next we shall move on for the properties of Z transformation. So consider the property 1 of Z transformation. So Zt of Z transform of n power k is equal to minus z into d by dz of minus z into d by dz of Z transform of n power k minus 1, where k is a positive integer. So now we shall see the proof of this property. Consider RHS of this property. Consider RHS. So what is RHS here? Minus z into d by dz of zt of n power k minus 1. N power k minus 1. Now use the definition of, to prove this, use the definition of Z transformation. We know that what is Z transform of un? Z transform of un is defined as summation n equal to 0 to infinity z power minus n into un. So using this definition, in place of un we have n power k minus 1. So substitute that n power k minus 1 in the summation, in the definition. So what you are going to get? So it will be minus z into d by dz of what is Z transform of un? It is summation, start with summation n equal to 0 to infinity z power minus n. What is un? In place of un we have n power k minus 1. N power k minus 1. So now here I want to find the derivative of this. Here we can interchange the differentiation and summation. So interchange that term, minus z into summation n equal to 0 to infinity d by dz of z power minus n into n power k minus 1. So now I want to find the derivative of this term. It is a constant term here. You are required to differentiate only the term containing z alone. So differentiation of z power minus n with respect to z. It is of the form It is nothing but derivative of x power n. What is derivative of x power n? N into x power n minus 1. So apply this definition. So it is of kx power n. So take out the constant term. So minus z into summation n equal to 0 to infinity n power k minus 1, as it is a constant term. Derivative of z power minus n is minus n into z power minus n minus 1. Z power minus n minus 1. Now take out minus z inside. So minus into minus plus. So z power 1. Z power 1. Here we have z power minus n minus 1 becomes what? The bases are same. Add the powers. So by loss of indices we can write minus n minus 1 plus 1. So which is nothing but 1 get cancelled, 1 and minus 1 get cancelled. You are left out with minus n. Inside the summation, you are left out with summation n equal to 0 to infinity z power minus n into n. Now similarly, bases are same of n. Add the powers. You are going to get the powers are k minus 1 plus 1. So plus 1 minus 1 get cancelled. You are left out with what? K. So it is n power k. The problem is of the form now. It is z power minus n summation n equal to 0 to infinity z power minus n un. In place of un what we have? N power k, which is nothing but what? Z transform of n power k by the definition of Z transform. So which is nothing but what? LHS. So hence it is proved RHS is equal to LHS. So this is the property called Z transform of n power k can be written as minus z into d by dz of Z transform of n power k minus 1. So next we shall go for standard Z transforms. So there are a list of standard Z transforms. Now we are going to derive that standard Z transform. In that first one, Z transform of k power n. Z transform of k power n. So by definition of Z transform, what is the definition of Z transform? Z transform of un is defined as what? Summation. Z transform of un is defined as summation n equal to 0 to infinity z power minus n un. So in the given definition, in place of un we have k power n. Therefore Z transform of k power n is nothing but summation n equal to 0 to infinity z power minus n into k power n. Z power minus n into k power n. So by loss of indices I can rewrite this problem as summation n equal to 0 to infinity k power n divided by z power n. You can rewrite this problem as k power n divided by z power n, since a power minus n is nothing but 1 by a power n. That is what I have done here. So and again I will rewrite this problem as summation n equal to 0 to infinity k by z whole power n. Now give the values of n here. So you are going to get k by z whole power 0. K by z whole power 0. Any real value raised to power 0 is what? 1. Plus k by z whole power 1 is k by z. Plus k by z whole power 2 is whole square. Plus k by z whole cube. Plus etc. So now we observe that the RHS is a geometric series. We observe that the RHS is a geometric series. So of the form 1 plus r square plus r cube plus so on etc. whose sum is given by 1 by 1 minus r. Whose sum is given by what? 1 by 1 minus r. Now substituting, equating the value here, we equating the RHS here. 1 plus r plus r square plus r cube. So where r is what here? K by z. Therefore the RHS becomes what? 1 by 1 minus k by z. So taking LCM here, in the denominator, I get z as the LCM, z minus k. Now, as it is a fraction here, we can rewrite this as z by z minus k. So that is what Z transform of k power n. What is Z transform of k power n? Z by z minus k. So after coming to know what is Z transform of k power n equal to z by z minus k, if I go with a particular case, so particular case as if k equal to 1, if I give k equal to 1, that is Z transform of 1 power n is 1 itself. Just replace z in place of k 1, you are going to get z by z minus 1. Similarly, if you give k equal to 2, it is of the form 2 power n. Z transform of 2 power n is given by z by z minus 2. So on, if you give Z transform of 3 power n, it will be z by z minus 3. So this is the way to substitute the standard form of Z transform of k power n for any constant value called k. So now next I require to find Z transform of n, and next standard Z transform called Z transform of n. So by property we know that by property of Z transform, we know that Z transform of n power k is what? Minus z into d by dz of Z transform of n power k minus 1. So now we know the property that is called Z transform of n power k is equal to minus z into d by dz of Z transform of n power k minus 1, right? So to get Z transform of n, so for what value of k you are going to get Z transform of n here. So if you put k equal to 1, n power 1 is what? N power 1 is nothing but n itself. Therefore Z transform of n is equal to minus z into d by dz of Z transform of n power. I am giving the value called k equal to 1. So 1 minus 1, n power 1 minus 1, n power 0. N power 0 is what? 1. So just now I have given the particular case Z transform of 1. Z transform of 1 is what? Z by z minus 1. Z transform of 1 is what? Z by z minus 1. Substituting that, minus z into d by dz of z by z minus 1. Now I should differentiate this with respect to z by using quotient rule, which is nothing but minus z into quotient rule, denominator square z minus 1 the whole square, numerator is what? Denominator z minus 1 into derivative of numerator, derivative of z with respect to z is 1 minus numerator into derivative of denominator, derivative of z minus 1 with respect to z is 1. So you are left out with what? Minus z into z minus 1 minus z divided by z minus 1 the whole square. So z plus z and minus z get cancelled. You are left out with minus 1 inside. Minus 1 into minus z is nothing but what? Z by z minus 1 the whole square. This is the standard form of Z transform of n. Z transform of n. Similarly, we have a standard Z transform for Z transform of n square, Z transform of n cube, Z transform of n power 4. We can find all the standard Z transform. Just I will give the list of this. Similarly, you can find the Z transform of n square. K equal to 2 here, you are going to get Z transform of n square, which is equal to minus z into d by dz of Z transform of n. 2 minus 1 is n power 1. Z transform of n, you know that Z transform of n is what? Z by Z minus 1 the whole square. Using this definition, we can find the Z transform of n square. Similarly, Z transform of n cube. Similarly, Z transform of n power 4. Here I have given the list of standard Z transform. So the left hand side is un. The Z transform of un is u bar of z. So Z transform of k is what? Z by z minus k. Z transform of 1 is z by z minus 1. Z transform of n is z by z minus 1 whole square. Z transform of n square is z square plus z divided by z minus 1 whole cube. Z transform of n cube is z cube plus 4z square plus z divided by z minus 1 whole power 4. Z transform of n power 4 is z power 4 plus 11z cube plus 11z square plus z divided by z minus 1 whole power 5. So this are all a list of standard Z transform which will be helpful for solving the problems of Z transforms. Now we shall move on to next property number 2, called as damping rule. The rule says that if Z transform of un is equal to u bar of z, then the statement 1 says that Z transform of k power n un will be equal to u bar of z by k. Then next definition says that Z transform of k power minus n un is equal to u bar of kz. Let us see the proof how to get the right hand side. So consider the Z transform of k power n un. So by definition of Z transformation, which can be written as summation n equal to 0 to infinity, summation n equal to 0 to infinity z power minus n into un, right? In place of un, what we have, it is k power n into un. So here we can write a power n as 1 over a power minus n. 1 over a power minus n. The reciprocal of a power n is what? The reciprocal of a power n is what? 1 over a power minus n. So similarly, we can write k power n as what? 1 over k power minus n. That is what? Summation n equal to 0 to infinity. Summation n equal to 0 to infinity z power minus n divided by k power minus n un. So which is nothing but what? Summation n equal to 0 to infinity z by k whole power minus n un. So what we are writing? By definition of Z transformation, Zt of un is always what? U bar of z. In place of z, what we have here? Z by k. So it is nothing but u bar of z by k. That is what? Z transform of k power n into un. So I can finally tell you that if the function un is multiplied k power n, just find out the Z transform of un, then replace z by k. Then just replace z by k in Z transform of un to get the solution of Z transform of k power n into un. Now if we go for the definition of second one, Z transform of k power minus n into un. So by definition of Z transformation, we can write this as summation n equal to 0 to infinity z power minus n into k power minus n un. So by laws of indices, we can write this as summation. We can write that as summation n equal to 0 to infinity z k whole power minus n un. By laws of indices, we can write that as what? Z k whole power minus n, which is nothing but u bar of k z. By definition of Z transform, we can write that as Zt of k power minus n as u bar of k z. So now you came to conclusion that if the function un is multiplied by k power minus n, just find out Z transform of un, then replace z by kz. Then replace z by kz in Z transform of un. That is what the second definition says. Z transform of k power minus n into un is equal to u bar of kz. Now if you consider some examples here, Z transform of n is what? Z transform of n is z by z minus 1 the whole square, right? Now I will find out what is Z transform of k power n into n. So n is un here. Yeah, un is multiplied by k power n. So just change z by k. Replace z by k in the expression of Z transform of n. So you are going to get z by k whole divided by z by k minus 1 the whole square, which is nothing but z by k whole divided by, simplifying this, take out LCM whole square, so which is nothing but after simplification you are going to get kz by z minus k the whole square. Similarly, we can also find out Z transform of k power minus n into n. That is what? Z transform of k power minus n into n. So just change z to kz. Just change z to kz. You are going to get, in place of this, kz divided by kz minus 1 the whole square. This is one of the example to find the Z transform of k power n into un and k power minus n into un. After coming to know the definition of Z transforms, properties of Z transforms, and list of standard Z transforms, now we are going with solving the problems on Z transforms. So consider the problem. Find the Z transform of e power minus an into n square. What we are required to find? Find the Z transform of e power minus an into n square. I want to know this value. The problem is of the form. It is of the form Z transform of k power n into un. How to analyze this? Problem? It is, here we have function of n square, a polynomial term called n square. Consider that as un. And this can be written as, we have exponential term here, it can be written as k power n. So the problem will be of the form called k power n into un. So Z transform of k power n into un is what? U bar of z by k. The final answer will be in terms of u bar of z by k. Now I will go with the comparison of the problem. In place of un I have n square. So I want to find out Z transform of n square. So according to the list of Z transformation, standard list, we have Z transform of n square as z square plus z divided by z minus 1 the whole cube. Z square plus z divided by z minus 1 whole cube. So I will retain this definition and I will apply this definition over the above equation. So therefore, in place of un, just I will put n square. You are going to get k power n, Z transform of k power n into n square is what? Replace z by k. Replace z by k. So it is nothing but z by k the whole square plus z by k whole divided by z by k minus 1 the whole cube. So simplifying this, taking LCM. So z square, LCM is k square here. K square by k we have. So LCM is k square, kz whole divided by. Also here also take out the LCM. Z minus k whole divided by k the whole cube. So simplifying this, we are going to get z square plus kz divided by k square whole divided by z minus k whole cube whole divided by k cube. So k cube and k square get cancelled. One term of k is left out here. That k will be multiplied to the numerator. It becomes k z square, k times of z square plus kz whole divided by z minus k the whole cube. So which is nothing but what? Kz square plus k square z whole divided by z minus k the whole cube. So this is what Z transform of k power n into n square. K power n into n square. Finally, what I want to find? Finally, I want to find Z transform of e power minus an into n square. So go with the comparison of what we have here, k. So k power n is equated with e power minus an. So it can be written as k power n, k whole power n can be written as e power minus a whole power n by laws of indices. So therefore I came to know that k is equal to what? E power minus a. So therefore Z transform of e power minus a whole power n into n square is nothing but what? E power minus a into z square plus k square. K square is nothing but k square can be written as e power minus a the whole square, which is nothing but e power minus 2a. So therefore it is e power minus 2a into z whole divided by z minus e power minus a the whole cube is the required Z transform of e power minus an into n square. Now we shall go for a very important problem in Z transform. Find the Z transform of cos n theta, sin n theta, k power n cos n theta, k power n sin n theta. So there is a chance of asking to find just cos n theta. So then also the problem procedure, whatever the problem I am going to give the solution here, the same solution carries for both here. If they ask either of the one, then also you should solve in the same way and give the conclusion. So now if you go with the solution, so here basically I know that what is Z transform of k power n. What is Z transform of k power n? Z transform of k power n is what? Z by z minus k. Z transform of k power n is z by z minus k. So as I want to find out the trigonometric function here, Z transform of trigonometric function, according to complex number, we know that e power I theta is what? E power I theta is cos theta plus I sin theta. Cos theta plus I sin theta. Or also you know that e power I n theta is nothing but cos n theta plus I sin n theta. I sin n theta. Knowing this definition, I am going to replace k by put k equal to e power I theta. Put k equal to e power I theta. So I will get Z transform of e power I theta whole power n is what? Z by z minus e power I theta. What? Z transform of e power I n theta is equal to z by z minus e power I theta. So multiply and divide by conjugate of e power I theta. So z minus e power minus I theta divided by z minus e power minus I theta. So multiply and dividing by that term, you are going to get z into z minus e power minus I theta all divided by z minus e power I theta into z minus of e power minus theta. So the numerator will be of the form now z into z minus of cos theta. This is what we are going to apply e power I theta expansion. E power I theta can be written as cos theta plus I sin theta. Instead of I theta, we have minus I theta, that can be written as cos theta minus I sin theta. Cos theta minus I sin theta all divided by. So now expanding the denominator here, z into z, it is z square. Next, z into minus e power theta is minus z e power minus I theta. Next, if you expand this minus z, if you multiply these two, it will be minus z e power I theta, right? So I will take out minus z as common. You are left out with what? E power I theta. Here, as we are taking minus z common, so you are left out with plus e power minus I theta. Again multiply these two, minus into minus plus e power I theta into e power minus I theta, bases are same, add the powers, e power I theta minus I theta. I theta minus I theta get cancelled. Therefore, e power 0 is what? 1. E power 0 is what? 1. Now simplifying this, what you are going to get? It is z into z square, z into z square minus z cos theta minus into minus plus z z sin theta all divided by z square minus z into, I should know the simplification of this. What is e power I theta? E power I theta plus e power minus I theta is nothing but cos theta plus I sin theta, cos theta plus I sin theta plus e power minus I theta is what? You are going to just replace plus by minus sign. You are going to get cos theta minus I sin theta. Therefore, I sin theta get cancelled. You are left out with 2 cos theta. So, which is equal to 2 cos theta plus 1. Therefore, it is nothing but what? Z square minus z cos theta. This is the real part plus I z sin theta divided by z square minus 2z cos theta plus 1. So this is nothing but what? Z transform of e power I n theta. I have told you what is Z transform e power I n theta. Expanding that, Z transform of, it is what? Cos n theta plus I into Z transform of sin n theta. Sin n theta. Just I have applied the definition of e power I n theta as what? Cos n theta plus I sin n theta, and splitting that Z transform, which will be equal to real part. Real part is what? This is what real part, and imaginary part is, this is what imaginary part. So separating real and imaginary part, we are going to get z square minus z cos theta divided by z square minus 2z cos theta plus 1. Similarly, plus I z sin theta divided by z square minus 2z cos theta plus 1. 2z cos theta plus 1. So therefore, I came to know Z transform of cos n theta is z square. Comparing this real part and imaginary part, z square minus z cos theta divided by z square minus 2z cos theta plus 1. That is what Z transform of cos n theta. Z transform of sin n theta is z sin theta divided by z square minus 2z cos theta plus 1. This is the required Z transform of cos n theta and sin n theta. Yet to find k power n cos n theta, k power n sin n theta. How to find k power n cos n theta? Just replace z by k in this expression. Similarly, replace z by k in this expression to get Z transform of k power n cos n theta and Z transform of k power n sin n theta. So now to find this k power n cos n theta, so we know that Z transform of k power n un is nothing but what? It will be a function of z by k. So therefore, Z transform of k power n into cos n theta. So already I know what is Z transform of cos n theta. Just replace z by k Fourier. So if I replace the value, I am going to get z square by k square minus z by k cos theta all divided by z square by k square minus 2z by k cos theta plus 1. So simplifying this, taking LCM in the numerator and denominator. So it is both numerator and denominator is LCM is k square. So k square get cancelled. So you are left out with z square minus kz cos theta all divided by z square minus 2kz cos theta plus k square as we have taken LCM. This is what Z transform of k power n cos n theta. Similarly, Z transform of k power n sin n theta is, we can write down directly, that is k replacing z by k here. So therefore LCM is k square in the denominator. It becomes kz sin theta, kz sin theta divided by z square minus 2kz cos theta plus k square. This is the required solution for k power n cos n theta and z transform of k power n sin n theta for the required question. Now we shall solve one more problem. Find the Z transform of cos hyperbolic n theta, cos h n theta, sin h n theta, k power n cos h n theta, k power n sin h n theta. So if I go with the solution, we should know that as we know the definition of hyperbolic function under trigonometric function called cos hyperbolic n theta. Cos hyperbolic n theta can be written as e power n theta plus e power minus n theta all divided by 2. Similarly, we know the definition of sin hyperbolic n theta is what? E power n theta minus e power minus n theta all divided by 2. So applying these two definitions, we can find the Z transform of cos h n theta and sin h n theta. So therefore Z transform of cos h n theta, cos h n theta is what? Z transform of this value cos h n theta is not in the list of standard form. So I am converting to the list of standard form in terms of k power n. So that is what? E power n theta plus e power minus n theta divided by 2. So applying linearity property for this, 1 by 2 is constant into Z transform of e power n theta plus Z transform of e power minus n theta, e power minus n theta. Now we know that it is of the form Z transform of k power n. What is Z transform of k power n? Z by z minus k. Z by z minus k. Here k is what? Here k is e power theta and here k is what? E power minus theta. K is what? E power theta and k is here e power minus theta. Therefore applying that definition, 1 by 2 times of Z transform of k power n is what? Z by z minus k. Here k is e power theta, so it is z by z minus e power theta plus z by z minus e power minus theta. So now taking LCM, 1 by 2 times of z minus e power theta into z minus e power minus theta. So here the numerator, you can take out z as common, z. So multiply the numerator by z minus e power minus theta plus of z minus e power theta. So you are left out with what? Simplifying this part, z by 2 times of z plus z is what? 2z minus e power minus, take out minus common, e power theta plus e power minus theta all divided by expansion of this is what? Expansion of this is what? Z into z, z square minus z e power minus theta minus z e power theta minus into minus e power theta into e power minus theta is what? 1. So I can take out minus z as common. You are left out with z square minus z times of e power theta minus e power minus theta plus 1. So now, as you know that the definition of e power n theta plus e power minus n theta divided by 2 is what? Cos h n theta. So similarly I can write e power n theta plus e power minus n theta can be written as 2 times of cos h n theta. So applying that definition here, I can rewrite that as z by 2 times of 2z minus 2 cos h theta divided by z square minus 2z cos h theta plus 1. So multiplying z by 2 inside, you are going to get the answer as 2 get cancelled, z into z square minus z cos h theta divided by z square minus 2z cos h theta plus 1. This is what Z transform of cos h n theta. Cos h n theta. Cos h n theta. So now I want to find Z transform of k power n cos h n theta. So just replace z by k in the above equation. You are going to get z square by k square minus z by k cos h theta whole divided by z square by k square minus 2z by k cos h theta plus 1. So as we get both numerator and denominator as LCM as k square, so multiply both numerator and denominator by k square, you are going to get z square minus kz cos h theta plus whole divided by z square minus 2kz cos h theta plus 1 is the required Z transform of k power n cos h n theta. Theta can be written as 2 cos h theta. So it becomes z by 2 times of 2z minus 2 cos h theta whole divided by z square minus 2z cos h theta plus 1. So multiply this z by 2 to the numerator, it becomes z into z square 2 by 2 get cancelled minus 2 by 2 get cancelled, z cos h theta whole divided by z square minus 2z cos h theta plus 1. This is nothing but Z transform of cos h n theta. This is what Z transform of cos h n theta. Now I can find out Z transform of k power n cos h n theta. Cos h n theta is what? Just replace z by k in the above expression. So we are going to get z square by k square. Z by k the whole square is z square by k square minus z by k cos h theta whole divided by z square by k square minus 2z by k cos h theta plus 1. So as you take the LCM in both numerator and denominator, you are going to get the LCM as k square. So just multiply and divide both numerator and denominator by k square. You are going to get z square minus kz cos h theta whole divided by z square minus 2kz cos h theta plus k square. That is what Z transform of k power n cos h n theta. Now we want to find Z transform of sin h n theta, Z transform of k power n sin h n theta, right? So it is very simple. See here, once you know how to solve Z transform of cos hyperbolic function and k power n k power n cos hyperbolic function. So here just replace sin by cos here. So you are going to get you know that sin h n theta is given by e power n theta minus e power minus n theta. So just replace minus sign here. So by linearity property you are going to get minus sign. So therefore here also you are going to get minus sign. Now taking LCM, be careful while taking LCM, that's all. While taking LCM, you are multiplying by minus sign, it becomes minus z, and here minus into minus plus e power theta. So minus z plus z get cancelled here. So the denominator will not be changed here. So you are left out with e power theta minus e power minus theta. E power theta minus e power minus theta all divided by z square minus z. I have taken out minus z common into e power theta plus e power minus theta. So therefore by definition of cos h, sin h n theta, I can write e power theta minus e power minus theta as 2 sin hyperbolic h theta. 2 sin hyperbolic h theta. Now multiply z by 2 inside. So you are going to get z 2 to get cancelled, z sin h theta. So which is nothing but z transform of sin h n theta. So therefore now I want to find out k power n sin h n theta. Replace z by k. You are going to get k z by k sin h theta divided by z square by k square minus 2 z by k cos h theta plus 1. So therefore finally taking LCM you are left out with kz sin h theta divided by z square minus 2 kz cos h theta plus k square, that is nothing but k power n sin h n theta. Sin h n theta. This is what the transformation for k power n sin h n theta, and this is the z transform of sin h n theta.